Hello, everybody. This is Bert Dixon. I'm here presenting on lesson 21.1 from our geometry text, which is on an introduction to some notation related to probability and set theory. And so a lot of this may be new material for you if you haven't worked with sets before. And so first of all, what is a set? A set is a collection of objects. Mostly we use numbers, but it can be anything. We could have numbers, we could have people's names as part of a set, we could have different types of fruit or vegetables or whatever. You can really put anything you want in a set. Most of the time we use numbers, and anything we put in a set, we put in these curly brackets. So if you just list all the members of the set inside the curly brackets, like it could be group A, group B, group C, those are called the elements of the set. And if we have a set with nothing in it, that's called the empty set, which uses this symbol. So like a 0 with a diagonal line through it means the empty set. Okay. When we're looking at sets, the universal set is all of the items that we're considering for that particular problem. And so we'll get examples of all those in this example below. So let's say set A is defined as the set of all prime numbers less than 10. So prime numbers are numbers that have exactly two factors, so usually 1 and itself. So 1 is not a prime number because it only has one factor, and that's 1. 2 is divisible by 2 and 1. 3 is divisible only by 3 and 1. 5 is the one we're missing, is divisible only by 5 and 1, and 7. All the other numbers in between 0 and 10 have, or between 1 and 10 have more than two factors. Like, for example, the number 4 is divisible by 4 and 2 and 1, so it's not prime. Okay, this notation, n of a, is that means the number of elements in set A. So we have 4 items in set A. I didn't mention this, but hopefully you already figured out we're working off of page 1083 in your book. So if you haven't already, make sure you have your text open to 1083 so you can follow along with these examples. Next, we're going to look at a set B that is even natural numbers. So natural numbers are the numbers you learn to count with when you're 2 or 3 years old and you're just learning to count. You don't start with 0. You don't include negative numbers. You just start, when you're learning to count, you say 1, 2, 3, 4, and so on. Those are called the natural numbers. And so we're looking for B is the set of natural numbers less than 10. So, even natural numbers less than 10. So if we list all those natural numbers out up to 10, 4, 5, 6, 7, 8, 9, 10. So the even numbers less than 10 would be 2, 4, 6, and 8. And again, the number of elements in set B is 4. Set C is a set of natural numbers less than 10 that are multiples of 4. So that would include only 4 and 8. And so set C has the elements 4 and 8. And so the number of elements in set C is 2. And so our universal set is a set of all natural numbers less than 10. That's this. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 wouldn't be in there because it says less than 10. So we could take 10 out. There's our universal set. And the number of elements in the universal set is 9. Okay, so continuing on to the next page, we'll look at Venn diagram interpretations of the same sets that we just looked at. Okay, so remember we said set C, if we use the same A, B, and C, it says C is a subset of B if every element of C is also an element of B. So this is the symbol we use for subset. And you can think of that kind of like a less than sign. So set C is a little bit smaller than set B, but it contains everything in it. And the Venn diagram shows that all the elements of set C are inside set B. So a good numerical example of that is exactly what we did here. We said set C contained 4 and 8 on the previous example, and set B contained 2, 4, 6, and 8. Okay, and so set C is a subset of set B because everything that's in C is in B. And so in this Venn diagram, we would have the numbers we would have the numbers 4 and 8. Let's try again. We would have the numbers 4 and 8 inside set C. Set B has 4 and 8 and also 2 and 6. And then the universe is all the numbers from 1 through 9. So 1, we've already got 2 there. 3 would be here. 4 is there. 5, 6, 7, 8, and 9. And so that's how the Venn diagram would work out. So we have the universal set contains all the numbers 1 through 9. So they're all in the box. And then set B, inside circle B, we have 2, 4, 6, and 8. And then inside of that, we have circle C, which has only 4 and 8. And so whenever we have a set that's completely inside another set, that's called a subset. This symbol is what we use for intersection. And we can think of that as where the sets overlap. Okay, so set B again, we said, is the numbers 2, 4, 6, and 8. Set A from our previous example was the prime numbers, I believe it was 2, 3, 5, and 7. Okay, so what numbers are in both? It looks like only 2 is. 2, so 2 is going to be in the overlap. Let me change colors, maybe you can see that a little bit better. So 2 is in the overlapping region. And set A has also 3, 5, and 7. So 3, 5, 7. B has 2, which is already there, 4, 6, and 8. And the numbers that aren't listed yet, let's see, there's only 2 more, and that is 1 and 9 would be out here. Okay, so that's intersection. Think of intersection as overlap. Okay, and also that symbol looks kind of like an N, so you can think of N, intersection, and that might help you remember what that symbol means. This symbol looks like a U, and it stands for union. It's the 2 sets joined together. And so we have the same 2 sets, A and B. So A again is 2, 3, 5, 7. B is 2, 4, 6, and 8. And so the Venn diagram doesn't look any different here. We'd have 3, 5, 7, 2, 4, 6, 8. But the difference is that A union B represents the 2 sets joined together. So if I join those 2 sets together, that includes the numbers 2, 3, 4, 5, 6, 7, and 8. And so that's what union means. It means you join the 2 sets together. We can go back to the previous example, and here we can write A intersect B. That would include only the number 2. Okay, and the last notation piece is called the complement. There are 2 different symbols that we use for complement. So the complement of set A means everything that's not in set A. So it's everything that's in the universe that's not in set A. And so we can use the superscript C for A complement, or when we use this symbol, we say not. So that means not A. So they both represent the same set. A complement and not A mean the same thing. It's all the things that are not in set A. So we said that in set A, we're going to have 1, 3, 5, and 7. So what's not in A? What's not in A would be, oh wait, sorry, A was 2, 3, 5, 7. 2, 3, 5, 7. So what's not in A? 1, 4, 6, 8, and 9. And so A complement includes 1, 4, 6, 8, and 9. Or you could say not A. What's not in A is 1, 4, 6, 8, and 9. So those two symbols mean the same thing. They mean everything that's in the universe that's not in set A. Okay, so we'll skip a page or so, and then at the bottom of page 1085, we're going to start getting into probability now. And so we're going to look at this is the basic formula for probability. The probability that event A occurs is the number of outcomes in event A divided by the total number of outcomes in the sample space. And so we'll do several examples so you can become familiar with what those things are. And so in this example, we're rolling a die or a number cube, 6-sided cube. And so it has the numbers 1 through 6. So that's our sample space. Every time you roll a die, these are the possible outcomes. So that's what sample space means. What are all the possible outcomes when you roll a die? There can be 6 different answers when you roll a die. Okay? Event A is rolling a prime number. So prime numbers are on the die are 2, 3, and 5. And so if we want the probability that we roll a prime number, we do the number of elements in set A over the number of elements in the sample space. So set A only has 3 elements, so there's 3 on top. The sample space has 6 possible outcomes, so 3 of the outcomes are prime out of 6 total, gives us a probability of 1/2 for our answer. So we did that part. Now the probability of A union B. So B, it says, is the event is rolling an even number. So set B would contain 2, 4, and 6. And so A union B, they have here already. A union B is all those numbers added together. So A was 2, 3, and 5. B was 2, 4, and 6. So if you put all those together, you get 2, 3, 4, 5, and 6. And so the number of elements in A union B is 5. There are 5 elements here. And so when we do the probability of A union B, that means probability of rolling. What this means is probability of prime or even. And so that's the number of ways that it can be prime or even, which is 5, divided by the total number of items in the sample space, which is 6. So we get 5 out of 6. A intersect B, if we have set A as 2, 3, 5, set B is 2, 4, and 6, then the intersection A intersect B would contain only the number 2. And so that's, remember, intersect is overlap. And so that these overlap only with the number 2. And so the probability of A intersect B, there's only one element in A intersect B out of 6 items in the sample space. So we get a probability of 1/6. A complement, remember, is the things that are not in A. So things that are in our universe is 1, 2, 3, 4, 5, 6. If we take out the elements that are in A, then we're left with 1, 4, and 6. So the number of items in the complement is 3, and the number of items in our sample space is still 6. So 3 divided by 6 is 1/2. Okay. For example B, I'd like you to go ahead and pause your video and try example B. See if you can fill in all the blanks on this page. Okay, so I've filled in the blanks on the sets here. And so the number of elements in the sample space is orange, apple, grape, broccoli, cauliflower, carrot, spinach. There are 7 items altogether. And set A, it says event A is picking a bag containing a vegetable. So if we put all the vegetables in set A, that includes broccoli, cauliflower, carrot, and spinach. That's 4 elements. So the probability of choosing a bag with a vegetable is 4 out of 7. So the number of elements in the sample space over the number of ways that event A occurs over the number of elements in the sample space. Okay, A union B, what this is the probability of vegetable, or let's see, event B is picking a bag containing all green food, so vegetable or green is what A intersect B. So whenever you see the union symbol, think of that as or. Okay, so the probability of getting a vegetable or a green food is, let's see, we have 1, 2, 3, 4, 5, 6. So there are 6 elements in there. So the probability of A union B is the number of elements in A union B, which is 6, over the number of elements in the sample space, which is 7. A intersect B, we haven't listed what B is, so that might be helpful. So B is all the green food, and so that is, let's see, they're green grapes, right? So we have grape, broccoli, and spinach. Okay, and so the intersection of A and B is going to contain broccoli and spinach. Those are the foods that are green and vegetables. So that has 2 elements in it. And so the number of elements in A intersect B is 2, and the number of elements in the sample space is 7, so we get 2/7. And then the probability, they didn't really say what to put here, but based on what we did in the last example, we did the complement. So probability of A complement, so the things that are not in A complement is all the elements that are not in A, so that's orange is not in A, apple, grape, and I think that's it. Okay, so those are 3 elements. So the number of elements in A complement is 3. The number of elements in the sample space is 7. So we get 3/7. Okay. Notice another way to get A complement is it's just the opposite of probability of A. So the probability of A complement is the same as 1 minus the probability of A. And so probability of A we got was 3/7. 4/7 from our very first problem up here. And so 1 minus 4/7 is 3/7. So that's another way to get the probability of A complement, is just subtract probability of A from 1. Okay, so let's go ahead and pause your video, and I'd like you to try problems 3, 4, 5, and 6 on page 1087. So read this problem, try those out, and then press play when you're ready to check your solutions. Okay, so we have numbers 1 through 30. So our universal set would be the numbers 1, 2, 3, all the way through 30. And event A is that you pick one of the first 10 numbers, so that's 1 through 10. Okay, and so the probability that event A occurs is the number of elements in set A divided by the number of elements in the sample space. And so there are 10 elements in set A. The sample space, I called it U, but that's also our sample space. Those are all the possible outcomes as the numbers 1 through 30. So there are 30 possible outcomes. 10 over 30 reduces to 1/3. So the probability that you are one of the first 10 students is 1/3. Event B is picking a multiple of 6. So set B is going to have 6, 12, 18, 24, or 30. And so we see there are 5 elements in that set. So so we actually should write down what A union B is. So if I join these two sets together, A union B is going to include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 18, 24, and 30. And so that includes 14 numbers. And so the probability of A union B is going to be the number of elements in A union B over the number of elements in the sample space. So that was 14. The number of elements in the sample space was 30. So that reduces to 7/15. And what that represents is the probability of picking one of the first 10 numbers or picking a multiple of 6. A intersect B is where these two sets overlap, and they only have one overlapping number, and that is 6. 6 is the only number that's in set A and in set B. And so this probability is number of elements in the intersection over the number of elements in the sample space. So that's one number out of 30. And the probability of A complement we can do two different ways. There are 10 elements in set A. That means A complement would include the numbers starting with 11. So 11, 12, all the way to 30. So there are 20 numbers there. And so the number of elements in A complement over a number of elements in the sample space, that's 20 out of 30, or 2/3. And remember, I showed you there was another way to get that. We could say probability of A complement is 1 minus the probability of A. So that's equal to 1 minus 1/3 is what we got for the probability of A. 1 minus 1/3 is 2/3. And so same answer, just a different process to get there. And so that second method that I was showing is demonstrated in this table here. It says the probability of A complement is 1 minus the probability of A. You could also do probability of A is 1 minus the probability of A complement. And that's because these two things have to always equal 1, because either A happens or it doesn't. So if we add those two together, that has to add up to 100%, which is 1.0. On page 1088, example A, they show how if you have two different events going on, we're rolling two different die. So we have one blue number cube and one white number cube. So the blue number cube can have outcomes 1, 2, 3, 4, 5, or 6. And the white number cube can have the numbers 1 through 6. So when you roll, there are 36 different possible outcomes. So that's these 36 different pairings that we get. And so the probability of rolling doubles, there are 1, 2, 3, 4, 5, 6 ways that we roll doubles, and out of 36 possible, so 6 out of 36 reduces to 1/6. Okay, so for example B, we can do something similar. This time we have a deck of cards, and by the way, in this chapter we're going to be working with cards occasionally. So if you're not really familiar what's in a normal deck of cards, I would encourage you to find a deck of cards and play some games with somebody in your family, or just spend some time going through the deck so you can understand what a normal deck of cards is. Because if you don't have a good understanding of what a deck of cards consists of, then it's going to make those types of problems really difficult for you. So try to become as familiar as you can with a normal deck of cards. And so in this example, we have the numbers 2 through 6 in red hearts. And so that's these items in the sample space for the hearts. And then a second pile of cards contains the numbers 4 through 8 in black spades. So we have those here. And then it says one card is chosen from each pile. What is the probability that the sum will be less than 12? And so if we go ahead and fill out the rest of this table, this is going to be 4 on the black card, 4 on the red card. This is going to be, in fact, I'm going to go ahead and just write the sum for each of these, because that's what we're looking for. So 4 plus 2 is 6, 4 plus 3 is 7, 4 and 4 is 8, 4 and 5 is 9, 4 and 6 is 10. If we have if our black card is a 5, 5 and 2 is 7, 5 and 3 is 8, 5 and 4 is 9, 10, 11. Then 6 and 2 would be 8, 9, 10, 11, 12. 7 and 2 is 9. 7 and 3 is 10, 11, 12, 13. 8 and 2 is 10, 11, 12, 13, and 14. And so we're looking for the sum to be, what is the probability that the sum will be less than 12? So I'm going to highlight all the numbers that are less than 12. Okay, and so if we count up all of those highlighted numbers, we have 5, 10, 14, 17, 18, 19. So I see 19 numbers that are in that grid. So the number of items in our let's see, what are they doing with A complement here? Let A be the event that the sum is less than 12. And so the probability of event A happening is going to be how many did we count? 19. 19 out of 25 were the sums were less than 12. And so to determine the probability of A complement, there are only 6 where that doesn't happen. So the probability of A complement is the number of elements in A complement, which is 6. Number of elements in the sample space is 25. So we get 6 out of 25. And so then going on to this problem continues on the next page. So the probability of calculating A, now we calculated it as 19 out of 25, but what this is showing is that another way to get that is to do the probability of A is 1 minus the probability of A complement. And so that's 1 minus A complement was 6 out of 25, and then that turns out to be 19 out of 25. Same answer we got when we counted all of the yellow. So the probability of the sum of 2 cards is less than 12 is 19 out of 25. So that completes our lesson on section 21.1. Have a great day.